At Hoodtronics, we are studying a maglev rotor for various unconventional motor design concepts. Here we demonstrate one of our first versions. Our tests require that we use electromagnet coils to drive the rotor. Since we are a small manufacturing company, we often design and build our own equipment. Today we will be using an esp32 camera controller, a magnet sensor, and an OLED to create a semi-automated power drill simple coil winding jig. You're watching Hoodtron is making. Thanks for coming. Now, let's get started. We designed the jig with rapid manufacturing techniques, which begins with computer-aided design, or CAD. Since we are using a power drill as the manual control point, it has to have a region able to fit the drill head. To automate calculation of coil turns and displaying it on an OLED, we need a microcontroller. The esp32 camera case module made by Hoodtronics and the associated microcontroller is designed to fit here. The secondary coil can fit on a stationary rotor and bearing located at the bottom of the 3D printed jig. A spinning magnet iterates a turn from a jig for a magnet detector called a 3144 Hall sensor. We use a 4-pin OLED to display outputs. First, we place the partly assembled jig onto the drill without demonstrating. The sensor, OLED, and microcontroller with associated wire are fixed in place. The power source for the jig will be from an Arduino microcontroller. Next, we add the primary and secondary winding coils. The primary coil is the coil to be wound for experiments. It has a magnet placed on it and secured with a 3D part. It is inserted into the drill's bit adapter. The secondary coil is unwound during the winding process and is secured onto the jig bottom with a stator bearing made from 3D printing. And now we have moved from idea sketching, concept design, and design testing to produce the esp32 camera Hall sensor semi-automatic coil winder. This jig was made for emergency purposes and for demonstration of how easy a device is made with modern tech. Thanks again for watching. Comment below for more information how to make the device.
Bye.